Hi, I'm Jonathan Paxman, Head of School for Civil and Mechanical Engineering at Curtin University. Engineering explores the application of scientific and mathematical principles to solve practical problems in the real world. It is about the design, analysis and testing of complex systems ranging from medical devices and assistive technology to autonomous vehicles, robotics, smart buildings and infrastructure. Engineers can be inventors, designers, builders and great thinkers. Engineers are at the forefront of the most important problems facing the world today, including addressing the challenges posed by climate change, transforming the world's energy and transportation systems, and addressing the medical and assistive needs of an ageing population. Curtin offers a 4-year Bachelor of Engineering degree with honours. The Bachelor of Engineering program is accredited by Engineers Australia, the professional body for engineering in Australia. Graduates from this degree satisfy Engineers Australia's Stage 1 competencies. This enables them to register as professional engineers in Australia or in many different countries around the world through the Washington Accord. Engineering degrees at some other universities require 5 years of study to achieve this level of professional recognition. Curtin's engineering program commences with a Common Engineering Foundation Year, or EFY, which teaches the core mathematical and technical fundamentals alongside engineering design principles, communication skills and professional conduct. In the second year, students choose to specialise in one of 9 majors: chemical, civil and construction, electrical and electronic, industrial and systems, mechanical, mechatronic, metallurgical, mining or petroleum engineering. Mining engineers work on the systems for extracting raw materials from the ground safely and efficiently. The mining engineering discipline is being transformed through automation and data analytics. Metallurgical engineers are responsible for the processes that transform these raw materials into more useful materials, such as steel, aluminium or copper. Chemical engineers are responsible for the processes which add value to materials to produce useful products. The Gorilla Glass on your mobile phone screen and the semiconductor chip in your computer are examples of the results of such processes. Petroleum engineers design and maintain systems which extract oil and gas from deposits below the Earth's surface. Civil engineering looks at the design, construction and maintenance of infrastructure and facilities for the community. This can include harbours and dams, water supplies and wastewater treatment facilities, railways, roads, bridges, and of course buildings of all shapes and sizes. Mechanical engineers are concerned with movement and energy. They maintain and operate machines and other moving systems, including flying and ground-based vehicles, as well as systems involving heat flow or moving fluids. Industrial and systems engineers focus on the design and optimization of a whole system rather than individual components. They explore problems in their entirety to create holistic solutions and processes for complex projects. Electrical and electronic engineering involves anything that produces or consumes electricity, including electrical power and renewable energy systems, electronic devices, computers and control systems, as well as the communications that allow all of these devices to talk to each other through both large and small distances. Mechatronic engineering involves utilising electronic and computer systems to control mechanical devices through the use of sensors and smart algorithms. Mechatronic engineers are involved in the design of robots and automated processes throughout industry and the community. In your engineering major, you will learn the core fundamentals of your discipline, alongside practical exercises and project work undertaken in our state-of-the-art laboratory facilities. You will also build your professional capabilities in areas such as engineering management, engineering for sustainability, and professional skills specific to your major. In the final year of your course, you will undertake a major research project on an individual topic of significance, while also developing specialised capabilities in advanced topics of your choice. Professional engineering practice is also an important part of your experience as a student engineer. Every student will achieve a range of professional experiences by the end of their course, which can include paid or unpaid internships in engineering businesses, training courses from professional engineering bodies, field trips or university-based work on industry-linked projects. The ATAR entry requirements for engineering at Curtin are an ATAR score of 80 or more, completion of mathematics methods ATAR, and completion of physics or chemistry or engineering studies ATAR. But if you don't meet the ATAR requirements or don't have an ATAR score yet, but are still passionate about an engineering career, don't worry. There are many alternative pathways, including the enabling course for science and engineering, the multidisciplinary science course, or you can also qualify through related diploma credentials. Available in 11 different fields, the Master of Professional Engineering is the newest offering at Curtin. This course is for people who already have a bachelor degree in engineering but wish to gain an advanced qualification in their chosen field. It is also a suitable program for science graduates who have been practicing in the engineering area, with a one-year graduate diploma pathway for students needing to bridge some of the technical foundations. Engineering students are involved in a wide range of activities outside their core studies. These can include designing a race car for the Formula SAE motorsport competition, or mentoring teams of high school students to engage in international robotics competitions. Many students have opportunities to be involved in research projects, which have an impact at the very highest level. As an example, some students have contributed to the design of Curtin's very own Binar space program, designing satellites to be launched into orbit around the Earth. Curtin students have been able to engage in mobility programs and undertake part of their studies at universities across Asia, Europe and the Americas. Engineering students have even had the opportunity of undertaking internships at NASA's Jet Propulsion Laboratories. Curtin's engineering graduates make an impact on the biggest challenges right around the world. So why not choose a career in engineering and join them? Thank you for watching. I hope you found this session valuable, and I hope you will consider Curtin Engineering for your future studies.